Class. My name is Angelique Blum, and I'm going to be talking about sundials today. So in my PowerPoint, I'll be discussing first, what is a sundial? Secondly, where did sundials originate from? Third, why sundials are important. And lastly, some interesting facts to know about sundials. Whoa, what is a sundial? A sundial is the earliest type of timekeeping device. Sundials show the time of day by the position of the shadow of an object exposed to the sun's rays. As the day progresses, the sun moves through the sky, causing the shadow of the object to move and indicates the passing of time. As you can see in the picture to the side, you can see the shadow moving about the sundial in a clockwise motion, and there's a bunch of numbers around the edge of the clock, which will indicate the time. And whatever time the shadow is landing on tells us what time it is in the day. On this slide, we're going to be talking about the parts of a sundial. So there's many different parts that go into a sundial and making sure that it reads correct time and making sure it works right. So from the picture, you can see that we have the dial, the dial plate, the gnomon, the hour lines, the shadow showing the time, and of course, the sun, which plays a huge role in making a sundial work. So first, we're going to go ahead and talk about the style. The style is the angled bit, which actually casts the shadow for the hours on the dial plate. And then we're going to go ahead and talk about the dial plate, which is where the hour lines and the shadow are indicated, and the style is directly in the center of the plate. The gnomon is often shaped like a triangle and is fixed to the dial plate. And then we have our hour lines, which are the lines marked on the dial plate to indicate the time. And then we also have our shadow, which is casted by the sun and indicates the hour on the dial plate. So all of these are very important to make sure that we can tell time on the sundial. But also keep in mind that none of these parts are mechanical. They're all fixed and they don't move. The only thing that moves is the sun. On this slide, we'll be talking about the different types of sundials that are out there. So first we have the horizontal dial, then the vertical dial, equatorial dial, polar dial, reflected ceiling dial, the portable dial, the analematic dial, and out of all of these different sundials, the most well-known sundial is the horizontal dial, and it is the one that we most commonly see today in society. So right there on the slide, there's a picture of a horizontal sundial, and these are the ones that we're going to be seeing in our examples throughout the PowerPoint. This next slide has a video on how a sundial works. So here you can see the sundial and its parts. Here is the sun moving throughout the day. And as you can see in the top left corner, it's showing the time. And as the sun moves throughout the day, you can see that the style then casts the shadow on the correct time. So right here in this last image, you can see that it's 1 p.m. during the day, and the sundial is showing that it is 1 p.m. on the dial. where sundials all started. So we don't exactly know where sundials originated from, but we know that the oldest known sundial was found in Egypt and dates back to 1500 BC. There were two strips of stone, one that did the needle and another where the hours were marked. So that was the first original sundial. It was just two pieces of stone put together. And then later on in Greece, later development of the sundial was the hemispherical sundial or the hemicycle, which was designed by the Greek astronomer Aristarchus of Samos in circa 280 BC. So here on this slide, we have two pictures of sundials. So the first picture on the left side is the ancient Egyptian sundial. And so you can see this sundial is a flat sundial and it's missing its genome. So you can see where that hole is, where that would have been to help create the shadow. And you can also see all the markings that were made to create the hour line marks. And then here on the right side, we have the ancient Greek sundial. And this one, you can see that it has that half circle. So you can see where it gets its name from. And you can also see the line markings, which were created for the hour marks as well. So on this next slide, we have a picture showing a Roman sundial. And so the Romans actually got their first sundial from the Greeks and got their first knowledge about sundials from them. So then from there, the Romans perfected the horizontal sundials we know today and also invented portable traveling versions. And so here on this picture, you can see that this sundial is actually on a little rope, and you can go ahead and bring it along with you when you travel back in those days, and you would be able to tell the time while you were traveling. And it was very convenient for them because that was the only way to tell time back in those days. Why sundials are important. So our first reason why sundials are important is because of telling time. So before the invention of our clocks, the sundial was the only source of indicating time back in ancient times all the way up until the 1900s. Another reason that sundials are important is because of prayer. In the past, Muslims, as well as some other cultures, after learning what Muslims were doing with sundials, they were able to use sundials to figure out times of prayer. So when they saw that it was a certain time on the sundial, they knew it was their time to pray. Another reason that sundials are important is because of clocks. Early on, clocks were not very accurate and needed to be regularly tuned by a sundial and compared to a sundial to bring them back to the correct time, because these clocks would either run fast or slow depending on the season's changes, because with a sundial you could tell the seasons change, but with a clock you could not. So lastly, we have some interesting facts about sundials. So our first fact is that when it's midday, the shadow on a sundial is short. That's because during midday the sun is at its highest point, and the shadow that it's casting on the sundial is going to be smaller because of how high up the sun is. So that brings us to our next fact. When it's afternoon, there's a longer shadow on the sundial because the sun is at an angle and it's casting a longer shadow on our sundial because of the angle that the sun is at. Our third fact is that the shadow on a sundial in the winter is longer than in the summer. The reason for this is because the sun is at different positions when it's either winter or summer. So depending on the season, the sun will be at different heights, causing the shadow to either be smaller or longer. Our fourth fact is that the sundial needs to point north and sit on a flat surface. So if a sundial is not pointing north or sitting on a flat surface, you're not going to get an accurate time read on the sundial. Fact number 5 is that the world's largest sundial is the Jantar Mantar in India, and it was built in 1734. And lastly, our last fact is that sundials are still used by NASA on Mars. So on the Mars rover, there is a sundial, and that helps NASA accurately read times. And it's very interesting that it's still used to this day because we have clocks now that are very accurate, but they still like to use sundials. So that's all for this presentation. Thank you so much, and have a great day.